Hello everyone. Welcome to my talk, and I hope you had a great KubeCon from the past one day, for the past 2 days, including the co-located event. So I welcome you all from today's talk. Myself, Yash. I will be talking about from like more towards building resiliency with effective backup and disaster recovery in Kubernetes. It's like this talk basically is my personal learning and the things that I implemented while I was working at a startup which is into security, and I was a part of our DevOps team who were working on the disaster recovery piece. But that's a piece of advice from my end. So who am I? I'm currently Yash. I'm currently interning at ChainGuard as a engineering intern. Apart from that, I'm a CNC ambassador and an AWS committee builder. Plus, recently I got CK certified. So if you want to talk about software supply chain or DevOps, I'm happy to chat with you. So before starting the session, this is the question: how many of you deploy workloads on Kubernetes? Most of them. So it's like uh, currently, if you are into cloud native, it's obvious to deploy your workload on K8s due to its uh, benefits and all the scaling functionality. So that's another question. Anyone of over you can identify any correlation between these dates that you tend to see, if possible? Yeah. Oh no. Yeah. Correct. So these are the dates which I shown over here are most of the major cloud outrages that you can tend to see in many regions. Basically, we recently saw Microsoft had a outage after CloudStrike had the invasion. So, like, if you see, that this is the major pain point why disaster recovery comes into picture and why it's important to consider for a org who tend to scale and build a who tend to scale up to a longer heights. And this that's a short definition about disaster recovery. The ability of a system to basically recover from failure include attacks, which may include attacks like ransomware attacks, service outrages that can happen to servers or any availability zone, and failures to any clusters or any region in which your production may have been deployed. So there are various kinds of disaster. I can say first is like the natural disaster, which tends to occur to any natural calamities that can happen to any server which is hosted on a particular location. Second is basically ransomware attack. There has been various cases where we can see most of them DDoS attack has been happening on most of the orgs, and this leads to the question of disaster recovery. And third, human action, which can happen due to an internal developer team or internal SRE team who are working by mistakenly. So once, like now we got the understanding about what's disaster recovery. And when we talk about disaster recovery, there are two critical points we talk about. One is RTO, which term as recovery point objective, and second is RPO. Or sorry, one is RPO, recovery point objective, and second is RTO, which is recovery time objective. So ideally, RPO stands for how much data we can lose if a disaster strikes, and like how much data we will be able to recover back. And RTO stands for like if our production goes down, in how many hours we can bring back the production up. And these two terms are like very critical if we talk about specifically to disaster recovery, because these two determines relevant, or I can say how well your infrastructure has been deployed and how fast you can basically recover back or restore it back. So there are various level of disaster. First is like minor, which can be a single cluster failure. If a small org is operating in a multi-cluster or small cluster region, that can be a single cluster failure, which we can term as a minor disaster. Second is moderate. It's like multi-cluster issue. Like you tend to have multi-cluster deployed on multiple availability zones, and most of them can go down at some time. So at that time, you can face the moderate one. And the major, which is like full region outage. Here basically DDoS also comes into this picture, like your whole clusters are basically attacked by ransomware, and then also the region is down. So if your production is in that region, hopefully it's gone, and until unless the region comes back, you don't have access to your production. And that can basically lead to a huge significant cost for the particular org, and also time and developer productivity. So once we got to understand what does disaster recovery means and what are the main point about, like what's the main concept about DR. Let's understand what's the challenges when we like we tend to face when we deploy or we can deploy things whenever we are doing disaster recovery. First is stateful and stateless workloads. So ideally, talking about this, statefuls are workload which tend to store states, and it's basically data sets and all. Whereas stateless are the ones with like pod deployments, where and this basically point tend to correlate with the GitOps model. Second is basically the complexity of multi-cluster. So when an org grows, it tends to scale their workloads to multiple cluster with the aim of due to compliance and security or maybe the expansion. So over here, managing multiple cluster is a bit more challenging as compared to managing a single cluster. And while creating a disaster recovery plan for this particular scenario. And third is basically the issue with the existing GitOps model. So the existing GitOps model don't tend to focus on deploying any database apart, like not in cluster but outside the cluster. So ideally, if you are deploying things on cloud, you can deploy in cluster database like example of MongoDB pod. But if you want to deploy RDS, that won't be possible with the help of GitOps. And the last is like if disaster strikes, what's the cost of it? Like it can be from small to a large, it can vary, and depending upon the work scale or the workload you tend to work on, it impacts a lot when you try to work on a larger scale. So let's focus on the main challenges that we see, that is the GitOps and its limitation. First is state persistence. So it in terms of state persistence, we can say whenever like GitOps is not when we deploy example when we deploy any in-house in-cluster Kubernetes database like MongoDB, we can track the deployment, but we are not able to track the state whether it's how much it's been stored. But in case of that's one of the limitation of GitOps. Second is real-time changes. If we see in GitOps, you can check live changes of pod deployment in the dashboard, but for database, it's not possible. You are not able to see the live changes. And then the recovery complexity. The stateless are able to easily recover back because you can easily redeploy them again and again because they don't store any data. But for stateful, it's not the same case and it's a bit complex. And this all three are like the main pain points or limitations we face when we are trying to work on disaster recovery, and we try to tackle them one by one. So this is most of the org infra, like most of them tend to deploy their work mission critical workloads onto Kubernetes. And then they addition to that, you tend to have any additional cloud storage like S3 bucket or any Lambda functions or RDS. But all these have been operated with the help of GitOps. So ideally, it's like an hub and spoke model where you tend to have a hub cluster which is connected to multiple spoke cluster, and you deploy things one at a time. So you click sync, and that basically syncs to all the cluster that you tend to have. So if you want to deploy RDS using GitOps, it won't be possible. And there comes two solutions for that. So when we were trying to work around this principle like disaster recovery, we came across two tools. First is Terraform and Crossplane. We made use of Terraform intensively to create the whole infra, starting from creating the subnets to working on creating the whole cluster and integrating the automation part. And then Crossplane, if you want to deploy things apart from like K8s, like anything on the cloud resources. If you want to deploy AWS Lambda function, that can be possible with the help of Crossplane. And since I worked on that particular DR for 3 months, Terraform was one of the uh, most of the tool that I use. And for that, I can say YAML is the best language I basically came across, and it's become more declarative. So if you see, you don't need to code anything, you just need to maintain a GitOps repo, which consists of a declarative way of all the things that you want to deploy. And how basically Crossplane works is they tend to have provider, and it basically works on the reconciliation logic where the desired state and the current state needs to be met. And Crossplane makes sure that anything that you are required onto the cloud resources like an Lambda function or RDS are being made available with the help of Crossplane. And we made the use of this particular tool with the Valero for the backup part. But this was the whole infra we tried to work around when we were working on the DR plan. And like this is one, like now let's talk about the strategies in disaster recovery. So if we see, it depends. So yeah, here whole four charts, I can say the whole four section depends from each org to org, because there may be some organization who are working into fintech or into gaming industry. They want resiliency a lot, so they don't want any downtime. Then in that scenario, you can tend to come with a multi-site active section where you can spend a lot amount of money, but they can to have a zero downtime. But most of them, since cost is a major factor when we talk about disaster recovery, we ideally go with the first one, backup and restore, where we make sure that if any disaster strikes, we should have a standby cluster in some another region, and a Terraform, I can say, or the whole Terraform and GitOps and Crossplane script ready, so that we can execute at any time at any time, so that our cluster is recovered back, our data has been restored, and backup is happening. So we went with the first option, that is the backup and restore, because cost was one of the things that we need to consider. But each of this depends. And another thing is, like, if we went with the first option, then the RTO and RPO tends to be ours, because we usually in our dev environment we used to take backups in a 6 interval of time. So our RPO was around 6 hours, because we can lose 6 hours of data if any production goes down. And for RTO, it was like 2 hours. So by the end of my DR work, we were able to basically stretch the DR plan. So the RTO is important thing. Like, if a production strikes, we were able to bring back our production in 2 hours. So that was the main, like, this was the initial hours that we gained, but it went on, it basically we worked more on that, and it reduced to 1.5 hours. So ideally, it's like whenever disaster strike, the important thing is like what's the shortest part you can get to basically work around your things, because it's not like you need to have all the automation ready. It doesn't mean you need to have all the Terraform scripts ready, because it's like it can happen anytime, and at that time, what's the best short way you can do so that your production can get up, your customers are happy with that thing, and there is no zero downtime. And afterwards, you can research more. I can say you can deep down into things like why did it happen and what are the reasons behind the disaster to happen. But yeah, for our scenario, we went with the backup and restore, and for and some critical workloads, we went with a pilot light for some of the workload, but highly it depends from org to org. And I will say, based on your org functionality, try to understand or try to basically get a note on which particular thing you came across. And this is a documentation I came across with AWS. So yeah, that's the one. Then what are the lessons we learned and we implemented? So once we got the understanding about what all things we want to do, now we focus upon what all scenarios, or I can say what all things we should implement, because our production was in multi-region, and we want to make sure that if any region goes down, we are able to work around with them. Like, at a time, within 2 hours, we can get that production cluster up. So first was region. This was the first scenario we worked upon, which was region failure. So like we worked upon, the whole team worked upon understanding if a region goes down, what all are the infrastructure that we require the most, and how can we recover back. So we worked along with Terraform and Crossplane to set up the whole infra, and we make sure that automation was the major thing, because most of the time you may not be present inside the org when disaster strike, and if the docs are proper, and there need to be a like feasibility between you and your team member. If your team member execute one single command line and the whole infra is up, that's what you wanted based on the disaster part. Because you don't have team members who know more about DR. They don't know Terraform, so it's like if you told them run this 10 commands, they won't be that feasible to run that, because they don't know the motive behind running that command. So it's ideal we also worked around automation. Second was availability, like one availability zone failure. So ideally, most of them over here tend to deploy your nodes in multi region, so that if any one region goes down, your traffic is being served to another node, and that's how your customers are also happy, and you are basically working through that. So we worked around this particular scenario, focusing on if any availability zone goes down, how can we recover them back. And the third one was cluster failure. This can happen due to some ransomware attack or any networking issue that you tend to have. So for this, ideally, this two, region failure and one availability zone failure, was a part of cluster failure. But we make sure that each of these tend to have a separate Terraform scripts and all the configuration present, because anytime anything can happen, and you should be ready with all the scenarios that we consider. And the last was database failure. So we were running MongoDB inside our in Kubernetes cluster. So we were not using RDS, we were using MongoDB, and we were running like we make sure that the MongoDB pods are in HP horizontal, like in HPA. So it's like if any one goes down, ideally it can make sure that traffic is being served by another two ones. So this was the four scenario we consider, but ideally this depends on each org. For us, we were operating on 10 clusters, but there may be org who may be operating at 100 cluster or 1000 cluster, and their scenarios or their learnings may be very different, because there comes a huge, I can say, scaling. There comes a huge problem about, not problem, but a huge number of clusters, and you need to make sure that each cluster's DR plan is ready, and each scenario, end case scenario, you are considering. So for us, these were the four major ones we focused on, and that's the one we basically worked upon. So this is one of the this was the whole plan around DR, and why we consider DR to be why we focused on DR was like, since our customer were growing, they were, and since we have seen most of the security issue in the past, we decided, and since being a security firm, we decided to work on disaster recoveries and for the compliance part also, and that basically boosted us to basically understand why this is required and how our infrastructure is up to date with the things that we are doing. So this is a small demo. Ideally, I can explain you. This was the whole setup. So what we were doing, like we were so we were not using Valero. We had some past issue with it, but ideally people tend to prefer Valero. It is also a great option for restoring back your data, which will come, that part will come forward. So we tend to have an EKS cluster. What we did was we were we were running MongoDB pods, which were storing data, and we made use of cron job. So that cron job used to take a snapshot every 6 interval of time and used to store in S3 bucket. People over here, if you know S3 buckets, like you can save a ton amount of GB of data in a fraction of cost as compared to any other thing, because S3 buckets tend to have a lower cost maintenance as compared to any other cloud storage. And then what we did was, like, we were prepared for let's take a scenario. If that region goes down, our S3 bucket was also present in the same US East region, and a cluster was also in the same region. And if that goes down, we don't have our data also, like the snapshot that we took is also present in the same region, and we won't be able to restore them back. So we made use of S3 cross replication, and we basically make sure that we selected one specific region on which we can basically take a snapshot of the same data that we store onto some another region. So even if that US East one anytime goes down, we had our data present in another region, and we can restore that, and we can take the we can restore that data in our any cluster that we want to stand by. We need to create, and then this is how happened. So if disaster strikes, we can see that the whole cluster can go away, but our data is present in another region. So it's like we can restore it back, and then again with the help of what can I say, Terraform, we were able to create the whole infra. And by the way, we were using, as I told, since we were using cron job to take a snapshot in a 6 interval of time, we made use of some manual script, bash script, that will make sure that once the restoration is done, like once the cluster is set up, the pods are up. Now inside the pod, what can I say, the data can be restored back, and that's how our production can be up again within 2 hours. This was the ideal way we basically went forward. Valero is another tool that most of them tend to use because it's a backup and recovery tool. And there are various other projects that we can see, like Canister is another one, which it's a sandbox incubating project inside CNCF that can be also used while working around disaster recovery. And then and that's the lessons we tend to learn. So first one was like, disaster recovery is not optional. We need to consider like disaster can happen anytime. You can't. It's like we don't have any control over that particular factor, and you need to be prepared for that particular thing. It's not optional. It need to be compulsory in your particular journey. Second is everything fails all the time. So this happened with me also. I had my DR ready. I tested it. It was like it was working around it took around 2.5 hours as a demo, but after a week it was not working because we made some changes inside our load balancing configuration. So our infra got updated, but we didn't update the Terraform file. So don't be in that delusion that everything will work once you create a DR. you need to keep on repeating that stuff in a 3 interval of time so that you are well aware about your infra and your DR. So like in an interval of 6 months, your infra can update, get upgraded to a newer level. So you need to make sure that your scripts are also updated with the same infra. And that's how basically the second points conclude. Third is basically unverified plans are no plans at all. So like never expect that things will go the way they are. It's not the scene because in DR nothing goes the way that we think. Every time the DR fails. So that's another point. Third is basically use auto replication that we did, because if people are over here using S3, do make sure to make use of the S3 auto replication, because that basically will make sure that your data is stored onto another region, and that's how you can restore the data back. Last one is like plan for multiple scenarios. So in our case, we basically plan for 4 scenarios or for 4 edge cases, and it depends, like multiple scenarios will depend from org to org. And last, it do document each and every step, because like if you are working and your team is working, another team may not be aware about what all things have been included in disaster recovery plan and how things operate. So like documenting that particular thing is way more important, and having that clear documentation is a must so that people are well aware about the things that are happening. So that's all about how we basically implementing disaster recovery in our org. So the previous org I was working was Nirmata, if guys know. It's a security-based firm and the parent of Kyverno. So we worked around this particular thing, and it was a great learning for me to understand why disaster recovery plays a critical role while org tend to scale and as they grow up scales. And yeah, so this is the QR. You can tend to scan, and if any questions, yeah. So.
You talked about the 4 scenarios, correct?
Yeah.
And how you have basically planned for those, because as you said, your script needs to be ready to do that disaster recovery, correct? So you might have planned some way to create that scenario also, correct? You repeated that to make sure the script is ready. So what all that you have planned from that perspective, how you have really done that disaster case?
So what we did was we make sure that with respect to each scenario, we had each separate repository, or I can say each separate thing. So if we are talking about one particular scenario, like let's consider region failure. So we do make sure that whatever infra we tend to, example, we were running EKS, but at the same time we were using other AWS services like load balancer, AWS Lambda functions and all. So I need to make sure that all that particular infra is well curated inside a Terraform script, because you can't basically run a thing and expect that okay the cloud S3 bucket will be created. No, like each and every step, like example from starting from load balancer to S3, we need to make sure each and every step were included, because each and everything was correlating with each other. Like we were using each and everything, and there was like if one thing is not present, you won't be able to deploy thing. Example, load balancer, and in that load balance also, like it's internal external, it's also critical thing, because for air gap environment you need to consider its internal load balancer. So ideally what we planned was like we made use of repositories to separate repositories and documentation well written, so to understand about each scenarios. That was the first thing we did. And coming up for the like how we decided what were the 4 corner cases we consider, because since our production were small, we didn't went too far, because cost was another factor. Whenever we try to replicate or retry disaster recovery, cost comes, because if I'm doing a disaster recovery plan, at the same time the whole production cluster has been created for an hour or 2 hour, and it tends to be, it may be present, but over that cost also can regenerate. So it was like we had a talk with other people, like a team member. We had some higher up who decided that these are the 2 corner case we need to have, because customer are requesting this, and they wanted this to be included in our overall business. That's how we basically concluded that these are the 4 that we can go forward.
Yeah, that 4 part is quite clear now. Thank you. I just want to know how you basically simulated the scenario is what I'm trying to say. It's like, one click here, how you really had simulated that part.
So with the help of Terraform, just one command like Terraform apply, we did make sure that the whole repo and things are up. If I'm not present, and if any sales team is working on, let's consider sales team is working. But if he wants to deploy things, just a one command. So that will initiate the creation of the whole infra. Okay, and we are talking about GitOps model also. So we also include GitOps model. So in case our hub and spoke both are getting created, both are getting connected to each other. GitOps model, GitOps pipeline are getting triggered. Pods are getting deployed. Once pods are getting deployed and they are ready, then the bash script gets executed, which will the bash script basically like restores the data from S3 buckets and store like takes the backup. And once that is up, we get the and we basically there is one was manual task. The load balancer URL we used to like we had multi accounts in AWS. So URL that we got at the end, we used to connect it to our domain, and that's how the whole production was up.
Okay.
That
Thank
was the
you.
whole seamless process.
Two two things I wanted to clarify. Ask you. So I have worked with Crossplane a lot, and it's one of my favorite tools. But it's yet not graduated
Yeah.
from CNCF.
Yes.
So in a situation of a disaster, how will you trust a
That's
tool that is not yet stable?
that's the reason we didn't focus a lot on Terraform. We
Yeah.
were only focusing 10%. Since Terraform was crossplane. Terraform is more mature project. We went with that.
But at the same time, Terraforms inherently do not deploy your applications. You mentioned that you are heavily dependent upon GitHub's Git, right?
Yeah.
And with Crossplane, I'm assuming you are implementing that GitHub's model with Argo in picture, considering creating of resources with Crossplane on your cloud
Yes.
account, right?
Yeah.
Now, in the hub and spoke model, the entire hub went down. You do not have anything right anymore. You replication is there, databases are there, S3 is there, everything is there. But now you have, like you mentioned, Terraform apply. It will create certain things, but it won't create everything, right? I mean,
Ye-
the
See.
and if something in cross point of time, how will you ensure that applications are up? And if not just application, the observability is there. There were so many things that
So
gets deployed
that's
there.
the after part. See, whenever disaster strike, it's important to make sure production is up. That's the more critical thing that you do.
But 2 hours still is a long window for
Yeah, I
any
can
disaster
consider.
to
Yeah, I
happen.
can. Since
And at the same time, we cannot just assume, right, that everything will work. Because it's a
that's the
disaster
corner case, right? You need to find the shortest way, and the shortest way
But
in
shortest, there are other tools like TerraGrunt. You can, if you completely eliminate GitOps from this disaster recovery
okay.
model, with TerraGrunt you can use apply Helm commands
And
directly.
I never came across that tool,
It's
but
a
yeah.
wrapper of Terraform. You
Okay.
can apply, you can run Python, you can run Helm apply, every single thing. What you need is a storage and an ACR replication. I mean ECR
ECR
replication.
replication, okay.
So tags are there, everything is
Got
there.
it.
You have TerraGrunt apply, it will create everything in 30 minutes or 40 minutes.
Uh,
I mean, why? I
No,
wanted to
no. I
understand
am
that.
see our backup part tends to take 1 hour.
Yeah, but backup is happening every 6 hours, right?
No, once
You
the
mentioned
snapshot is taken like it takes around 6 hours. When we restore back the data, it takes around 1 hour to restore. That much amount of data we have.
but at the
So
same time, that 1 hour can be used till our clusters
yeah,
are coming up.
that's the after. Yeah, I can agree that, but for me, as I working, I got to know that 1 hour is a huge. We can consider that part, and getting 2 hours of time is also a huge. Mostly people tend to say that getting bringing back production half an hour is a great thing, but again we can work on that. But ideally, our restoration process used to take 1 hour, and our infra was ready at 40 minutes at max.
Okay,
Yeah, that was the thing.
thank you.
Back.
Yeah, so you told, so what is the frequency at which the snapshots are taken?
In dev, we used to take 6 hours of in devs 12 hours, and in prod 6 hours.
Okay, so which means that there's a possibility of losing almost 5 hours 59 minutes of data.
Yes.
If the snapshot is okay.
Yeah, I agree.
That's the RPO that you are considering at this point.
Yes.
Okay, so the question is, so you have shown like 4 or 5 ways of the
Scenarios.
this not scenarios as such. I mean, the way we can do the DR, right? In the first slide, that one is the disaster,
Yeah,
one
yeah.
is the backup,
The types of
second one
disaster.
is the pilot light or something, and so
Yeah.
on. Right?
Okay.
Yeah,
Strategies. Yeah.
the strategies, right?
This
So
one.
this one, yeah. So I wanted to know because I think for most of the, let's say, financial institutes, the it has to be almost real time. There should be there should be zero RPO, and RTO can still be in minutes, right? And again, there are two more scenarios. One is whether the snapshot that they're taking are application aware snapshots or are they crash consistent snapshots, right?
Okay. Yeah.
So, so
Correct.
in this scenario, the way I see, especially for backup and restore, they are largely crash consistent snapshots. They are not application aware snapshots,
Okay.
right? So how, and especially in the case of transactions, databases, I mean like financial institute, right? It need to be application aware snapshots. So I don't think that was not the use case for you.
Ideally, no. But we were working more towards like, do you Kyber? You know Kyber, no? So basically, Nirmata is a SaaS product of that. So
Okay.
over there, we didn't financial working around financial part was not critical for us. Providing compliance and security was the important thing. So that use case didn't came only for us to work around with that thing, because once we provided the services to them, now our point is to make sure that they are able to use our services, the SaaS product that we tend to sell. That's how, and due to that, we didn't consider that
Okay. So the
factor.
compliance is only for 6 hours RPO.
Yes, like
Okay.
it
Interesting.
because also your part is like 6 hours. You can tend to keep 2 hours also, but now your fact is your S3 bucket can cost can go up.
Because the 1 hour that you are talking about, right, for restore, that is also a function of the amount of data that you have to restore,
Yes.
right? Uh, sure. Any solution at this point do you see for almost real time or near real time at this point for the recovery and the restore?
Near real time, like the last one, no.
The last one and the warm thing, I'm not sure what is warm standby, but yeah, I think, let's say, are there any existing solutions at this point for
Apart
Kubernetes
from this four,
apart from the backup and restore? That is a relatively easy problem, right?
yeah.
Backup and restore. But is there anything for near real time or something that comes in the category of warm standby at this point? Is there anything in the market at this
I
point?
think not sure. I need to work around that. I'm not aware about anything, but I can reach out to you and provide you update after that. Not sure
Sure,
about
sure.
it. Yeah.
Yeah, I mean the question for everyone in the audience as well.
Sure.
Hi. So yeah, my question is regarding like how you guys are able to manage route the traffic in the case of like availability zone failover, like what exactly you did.
Can you elaborate on that more?
Like suppose there is like region A or zone A, zone B,
Yeah.
and if zone A goes down, you need to route the traffic to zone B, right? From the A's, like from Fastly or Cloudflare or whatsoever. So like how you guys were doing.
We were using AWS WAF along with our. So what happening whenever our cluster, like example, let's consider that whenever the cluster was up, we tend to get the URL. So ideally, we used to manually take that load balancer URL and associate it to the route S3, which is present. So that's how we were working.
Okay, so is this a manual effort or like is
That was a
automated?
manual step because that was the end step to check whether our whole process is complete or not. And we basically kept it manual so that we are able to understand कि okay, data is getting restored, we are getting the cluster is getting up, we are able to read the traffic. And because of that, we kept that manual step, but it depends now from company to company.
Got it. Thank you.
Yeah, hello.
Yeah.
Regarding backup and restore, you mentioned Valerio, right? I mean, for Valerio is for only EBS when we use the EBS volumes in AWS. What about for EFS? When we use the EFS, so Valerio is not compatible.
I guess I don't have much availability on that.
Okay.
We never came across EFS in our whole infra.
Okay.
So, but I can have a talk after
No,
this.
no worries. Thank you.
I was just saying that you have a EFS plugin also. You have to just get it connected to the Kubernetes and use Velero to connect that EFS and drop the backups. There is a possibility, but EFS is not so good a place where you can put. It is not cost efficient. So S3s are mostly being used. So that's the only difference. So
Thanks for that.
one question I had is the edge cases, yeah? So you just think in a way that the region is gone.
Okay.
So when the region is gone, it is not only for us or whoever is hosting the resources, right? So it's a whole bunch of lot of
Correct.
things. So we starting the same resources at the other region. How effective we can manage the risk of not getting the required instance types and stuffs. So which can again affect the RTO RPO, right? I mean, you are in a need, in a bigger need overall if you see AWS. The other region is going to start getting a lot of requests for resources, not only from us, right?
Yeah.
How we can deal with such edge cases when the RTO RPO is stringent?
So one thing is like when we work around DR, we do make sure that we know our requirements. Okay, this is at max this thing particular node size is what we want, we will try to replicate the same. But for this also to happen, like ideally what happens is we make sure that every 3 months we are having a DR demo. Ideally, like we are practicing about whether the DR we created 3 months ago is still working or still relevant or not.
Yeah, I was just not mentioning the process. I was mentioning on the capacity what we need at the other region, because we are not the only one who is requesting the resource, right? Because a
Yes.
lot of other requirements also comes into that same region, right?
Yeah.
So there is a normally an
It's
edge
like
case wherein we used to say that we might not be able to get the required compute capacities when we try to bring up the infrastructures.
ideally, see, if in this scenario we consider a region which is not well, I can say, used by most of the companies. Like we try to use, it's a smart play over here. Where based on your research and all, which particular region you think is not been utilized more, and you can have that in backup, because let US East one, US West one are most of them use, and they are less like cheap. So here we can say, if you are like considering that a factor, like cost can go up and you can go to a region which is a little bit costly, but at the same time people are not deploying over there. So it's more relevant to deploy over there, because at the time of disaster where all the companies production may be gone down, you are at a safer side to work around that.
Thank you.
Yeah.
Hi,
Yeah.
what are the key differences you observe between Crossplane and Terraform?
So we didn't use Crossplane as much as Terraform because it's not that mature to use. Ideally, it's in incubating stage. And because of that reason, we basically just use that for deploying our Lambda functions. Just for the use case of Lambda function, we made use of Crossplane.
So Terraform also supports, right?
But we were not able to automate the thing that we wanted with the help of Terraform. We tried using Terraform and we were like facing some issue with respect to that. And because of that, we consider alternative for that particular specific like point, and we shifted to Crossplane.
And for GitOps, you are using Argo CD?
Yeah,
Or?
yes. It basically it deploys whenever used with the help of Terraform. It tends to deploy, and GitOps model tend to have that GitOps sync where you can it automatically register the cluster and hub and like in hub and spoke model you need to register cluster. So Terraform makes sure that both the cluster are getting registered equally and things are getting deployed, and there is a sync between them.
Thank you.
Any more questions? Okay. Let's do one thing. It's like over the time we can have a chat outward. Works? Okay. Thank you everyone. Thanks for joining the talk.